I built this basic UDP server with assembly. Let me explain what I have did here. In the beginning, I declared some constants. So first of all, I have finet, which is stands for IPv4. This is equal to 2. And sock stream, this is the option for, this is the type of the socket. When we have to create the socket, we have to define it. The sock stream is used for the TCP connections, and this is the protocol number of TCP, and this is the message. Whenever any client connect us, we will send this message, and we are also counting the length of the message so we can use it when writing it. In the BSS section, we storing some bytes for future use, like the socket file descriptor. Whenever my server will listen in any specific IP and any port, this will be created. So I will store the socket file descriptor in this, and this will be the client socket file descriptor. Whenever any client connect to me and I accept the connection, then this will be created. Instead, first we creating a socket. The create socket, you can see we're moving 41 in RX register. 41 stands for the sys socket. If we come here in Linux syscall table, the 41 is actually for sys socket. For creating socket, first we have to provide it the family. Family is it IPv4 or IPv6? In our case, it is IPv4, and for IPv4, we are providing finet in RDI register, and this is the type actually which type of connection, which type of socket we are creating. So this is the socket stream. This actually used for TCP connections, and this is the protocol number of the socket. So in our case, this is TCP, which is 6, and after syscall, if it successfully create a socket, then it will store the socket file descriptor in RX. So I'm assuming this successfully created a socket. So after that, you can see I'm moving RX to the socket file descriptor. After creating the socket, I'm binding the socket. So in the bind socket, you can see that I'm moving 49 in RX. If I come here in the syscall table, you can see the sysbind also accept three parameters. First one is the socket file descriptor, and the second one is the structure of socket address. This will be the my server socket address, and this is the address length. So if I come here in our code, we can see first of all I'm providing the socket file descriptor of my server, and then this is the socket address structure. If I come here at the end of the code, you can see the socket here. This is the address structure of my server. In the family, I have finet, which is IPv4, and port. The port is actually here is 2929, and this is the host which IP the server will listen. So this is the 127.0.0.1, which is my default loopback IP address, and this is padding, and this is the length. We basically counting the length of this thing, this socket address structure, and this is a placeholder socket structure for client. Whichever client connect, the client socket address structure is stored in here. If I come here in bind, I'm providing the socket address and and then the socket address length, then Cisco. This will bind my socket to listen on my default loopback IP 127.0.0.1 and in 2929 port, and then in listen, I'm just providing the socket file descriptor. When I come here, we can see the 450 it accept first of all file descriptor and then backlog. So I can say I'm providing the file descriptor, and backlog I'm providing 5. Backlog is actually how many connection can stored in our queue before accepting the connection. So this is networking start. Then we calling accept. If I come here, you can see after listen, I'm calling accept. So the accept. I'm moving 43 in Rx register. 43 is actually sys accept. It accept three parameter. First one is the file descriptor, second one is the client socket address, and the third one is the socket address length. So I'm providing the socket file descriptor of mine, and this is the case holder socket address structure I created, and this is the length of the socket address structure. And after syscall, it will create a socket and put the socket in Rx register. Store the socket is Rx register. This will be the client socket file descriptor, whichever client connect to my server. So I am moving the Rx in the client FD, so I can use it later when writing any data in our client socket. And then I'm calling write to send a basic message to our client. So in here in write, I'm moving one to Rx. One is for syswrite, and it accepts three parameters. First one is the file descriptor, second one is the message I have to write, and the third one is the message length. So this is the client socket file descriptor. I'm getting this from here when accepting it, and in the second parameter I'm just providing the message which we have declared at the beginning of the code, and this is the message length. And syscall, this will write a basic message to our client socket. So it's basically send a message to our client. So let's see this is working or not. First of all, I'm compiling the code, and now I can run the server with server -tcp, but I am running it with the a debugger, so we can see what's happening behind the scenes. So if I do SQL network, you can see here this is creating a socket with FINet, which is IPv4 sock stream, which is used for TCP, I said, and this is the protocol of TCP, and it's returning 3. This is a positive number, so there is no error. And then it's binding the 3, which is my socket file descriptor, with this. This is the socket address structure of my server. So you can see all of these things, and this is the length of this, and it's listening on 3, basically the socket file descriptor with the backlog 5, and then it's accepting any upcoming connection. So let's try connecting with netget. It will connect to 127.0.0.1 in 2929 port. So let's see, is it working or not. I'm putting -b plug so we can see everything. So let's enter. You can see here the hello from TCP server message arrived. First of all, the connection to localhost 2929 succeed. Then the hello from TCP server. This actually the message here. You can see whenever we accept any connection, we're writing the message. So this is arriving from here, and you can get this code in the description. I'll see you in the next time. Thanks for watching.